Genetic engineering. It's been present in our popular culture ever since H.G. Wells wrote the book The Island of Dr. Moreau over 125 years ago. Since then, it's been vilified, celebrated, scrutinized, embraced, condemned, and also championed. I wrote down an even longer list of adjectives to describe both good and bad, but I think you get the idea. The ethics of pursuing genetic engineering technology have been hotly debated for decades now. But with these technologies becoming more accessible to average people, how long will it be before altering our genomes becomes a regular part of society, or even something we could do at home? Will we regret not taking the time now as a society to define what's the right and wrong way to develop and distribute this kind of technology? The Island of Dr. Moreau was the first piece of recorded media that describes someone performing a procedure like genetic engineering. It follows a shipwrecked man who encounters the enigmatic Dr. Moreau on the island. He learns Dr. Moreau is conducting unethical experiments, transforming animals into humanoid creatures through an early form of genetic engineering. If this story sounds interesting to you, then you should buy the book on Amazon or something. I don't know. I didn't read it. Reading's for nerds. Who has time to read anyway? Especially a book written over a century ago. It's probably all old-timey and confusing. Plus, the monsters in the movie look kind of gross. H.G. Wells wrote this book about 30 years after Gregor Mendel did his thing with the peas. You know, the monk guy with all the different color peas, you know, with the Punnett squares and stuff. If you don't know, he basically proved that flower color and seed shape are passed down from parent flowers to their offspring in predictable patterns. And there weren't too many advances in the field of genetics in between those two things happening. The term genetic engineering was first introduced in the early 20th century, but it remained largely theoretical and associated with science fiction until practical methods and tools for manipulating genes became available in the 1970s. It's around then that scientists were able to use restriction enzymes to cut and paste DNA in between organisms. This led to stuff like genetically modified food and eventually CRISPR-Cas9, which you could say was much less restricted than restricted enzymes. All right. Restriction enzyme technology can only cut and paste specific predetermined locations of DNA. It's a protection that bacteria have built in to help them recognize and evade viruses. We just decided to hijack it. But CRISPR is a more advanced protection, although we also stole it from some bacteria. The CRISPR system includes Cas proteins, which can be programmed to locate very specific portions of DNA and perform more precise cuts than restriction enzymes. Obviously, way more complicated than that, but I don't really have time in this video to get into it. It was first discovered in 1987, but it wasn't until 2012 that the teams behind researchers Emmanuel Charpentier and Jennifer Doudna independently showed that CRISPR-Cas9 could be harnessed as a gene editing tool. And in the decades since then, the technology has taken off like a wildfire. Or is that bad to say right now? It's taken off like a virus? It's taken off like geese? They take off. CRISPR is what people are talking about when they describe modern genetic engineering or gene editing technologies. And even though H.G. Wells' Dr. Moreau didn't know what a DNA was or what a modRNA was, the ethical themes of altering life through scientific means in this book are still concerns we face with today's genetic engineering technology. Yeah, maybe I bought the book, okay? And just as the Island of Dr. Moreau has laid the groundwork for exploring the moral and ethical implications of genetic engineering, it's also helped me lay the groundwork for the rest of this video. But before I get into that, I need to introduce you to Joe Zahner and the Odin. At the Odin, we believe the future is going to be dominated by genetic engineering, and consumer genetic design will be a big part of that. We are making that happen by creating kits and tools that will allow anyone to make unique and usable organisms at home or in a lab or anywhere. A few months ago, I saw an article about this company who are offering at-home genetic engineering kits, and I became immediately interested. I assumed by unique and usable organisms they were talking about like fire-breathing dragons, which would be useful ever since the igniter on my grill broke, but it wasn't that. At first, I thought it'd be cool to do a video where I buy one of these kits, do some science with it, and then talk about the ethical implications of being able to do genetic engineering at home. After all, I worked in biology and chemistry labs for nearly 5 years and am something of a scientist myself. I told myself I wasn't going to make the SpiderMan joke. Oops. I also wanted to buy one of these kits just because I thought being able to make unique and usable organisms at home sounded really fun. If dragons were out of the question, I thought maybe I could design something more realistic, maybe some sort of insect-mammal hybrid. I was thinking something that like sticks to walls and uses its immense strength and moral compass to fight crime. It's just Spider-Man again. As a former scientist who doesn't get to spend time in the lab anymore, I sometimes miss getting to work with things like 0.1 milliliter microcentrifuge tubes containing LB broth, or 0.1 milliliter bacterial transformation buffer, 25 millimolar CaCl2, 10% PEG 8000. But when I got to the site to make my purchase of what I assumed would be relatively harmless lab tools and bacteria, I found something that I didn't expect. The site was selling more than just fun little DNA kits for children. They were selling kits costing multiple thousands of dollars in classes dedicated to teaching people how to genetically engineer human tissue. I guess at home. They sell human embryonic kidney cell lines right on the site and everything, which I had previously only seen in markets in Tijuana. So naturally, my next thought was to try to find the about page for this company, because I needed to find out exactly what they were. Like, why exactly were they teaching people to genetically engineer human tissue at home? And that is where I found the biography of the Odin founder, Joe Zahner, and began to seriously reconsider whether or not I should even be buying anything from this site, or if purchasing something would put me on some sort of government list. The founder is a PhD who spearheaded work on developing engineered microbes for Mars terraforming at NASA, and eventually left to start the Odin, a bioengineering company based in Austin, Texas, that is working to make genetic engineering accessible to everyone. Zahner's groundbreaking work in human genetic engineering and medicine has been the focus of many documentaries, including the Netflix documentary Unnatural and the New York Times documentary Gut Hack. So that all sounded good, but it was the next part that made me pause. They've been made fun of on Last Week Tonight with John Oliver and written about in media all over the world, including the New York Times, the New Yorker, El Pai, Le Monde, Time, Scientific American, and NPR, among others. And when I Googled Joe Zahner, I found a bunch of articles about how they were being investigated for practicing medicine without a license. Now, a biochemist selling kits online that contain human tissue, that seemed like it was probably fine. But a biochemist who's selling human tissue online and is also being made fun of and being investigated for medical fraud, that's where things started to get a little bit fishy. So I decided that before I could, in good faith, purchase anything from this site, I had to make sure this Joe Zahner was worthy of my trust. And that Netflix documentary I mentioned sounded a lot more fun than reading, so I mean, you get it, you're watching this instead of doing anything productive. I watched all 4 hour-long episodes of it, and I'm going to tell you about it. Before we start, I want to say that Joe Zahner is kind of a wild person and has clearly been harassed in a lot of different media. So I'm going to try my best to not make too many jokes about them, because I think that would be unoriginal. That being said, to get an idea of some of the controversies surrounding Joe Zahner, I put together a few clips of John Oliver making fun of them.
Look, he's basically selling chemistry sets, and to the extent that they get people excited about science, that's a good thing. But you can see why scientists get frustrated when biohackers like Zahner hog all the media attention, especially because he makes some pretty wild statements like, I want to live in a world where people get drunk and instead of giving themselves tattoos, they're like, I'm drunk, I'm going to CRISPR myself, which is a terrible idea. Now, last October, Zahner even publicly injected himself with DNA that had been modified using CRISPR to try and give himself bigger muscles, which did not work. But in that same video, he argued that using CRISPR should ideally be like downloading an app.
You don't have to know what the app does, how to program it, how it works, anything like that. And I think that's the way it should be with genetic engineering and synthetic biology. Why can't people use this technology without necessarily completely knowing how it works?
I can answer that one for you, because it could be dangerous and someone could get hurt.
So, you know, this guy seems like a good time, but that doesn't always translate to being a good scientist. Joe Zahner is introduced about 20 minutes into the first episode of the Netflix documentary, where they describe the operations of the Odin and some of the organization's main goals.
I was hearing a lot about CRISPR, and I thought, what if I could make a protocol that wouldn't have to be done in a lab, but could be done in a home? If we can give access to everybody and could completely change the balance of power.
These themes of balance of power and providing access to the poor are really big for Joe, and they mention it several times throughout the documentary. Equitable access to therapies are a legitimate concern and one of the most commonly debated topics in the gene editing community. And I commend Joe for being concerned about it. But at least early on in their career, they seem to ignore a lot of the potential dangers of everyone being able to mess with their own genomes, in favor of the idea of some sort of utopian future where everybody uses this technology responsibly.
What are we left with? We're left with a lot of athletic, attractive, healthy people. Like, ooh, that's gonna be a terrible world.
It's true that people are allowed to buy chemicals and biomaterial and do whatever they want with it if they have the means. But Joe Zahner and other biohackers, as they're called, who want to be able to alter genes in their garage, sometimes appear to forget that precise genetic engineering is a process best performed in a sterile environment with really dedicated, specific, and expensive equipment. It's easy enough for people to get hurt just by getting the wrong dose of a chemical vehicle they might inject themselves with, before creating the opportunity for them to missplice their DNA and create some kind of terrifying real-life Bioshock world. Like, it's nice to think about how increased accessibility to these opportunities will level the playing field. But now think about your most reckless friend from high school attempting to alter their genes in their garage. Thankfully, though, it seems like Joe makes a realization and has a change of heart towards the end of the last episode.
I have to be more careful with what I say now, because people are fucking listening.
So while I'm still a little bit sketched out by some of the Odin's business practices, like keeping food in the freezer next to their biosamples, and generally just doing everything out of a garage, or being investigated for practicing medicine without a license, most of their stuff seems genuinely educational, and at this point I was curious to see just how easy the Odin made it to do genetic engineering at home. So I guess, against all odds, I've decided that Joe Zahner has earned my trust, but maybe not enough to buy human cells from them. I decided to go with the nice, modest $40 genetic design starter kit for this video. I got it because it involves putting a glowing jellyfish gene into E. coli bacteria, and my girlfriend Erin's favorite animal is a jellyfish. So I thought she would be excited and would want to help me do the experiment. But actually she was kind of disappointed when she found out the experiment didn't involve any actual jellyfish. But that would make the experiment more fun, so take notes. At the Odin. Take notes. Ultimately, she did agree to help me with the experiment. At this point in the video, I was going to perform a reenactment where I pretended to put the kit in the cart and buy it in the moment. But I'll be honest, I bought it like 11 days ago and I have it right here. So let's go play with some kit I bought from a mad scientist garage. This is Erin. She's never done anything like this before, right?
That's right.
So no science labs or anything. It'll all be new. The first steps, I think, were to just get everything.
Wait, do I wear gloves too?
Yeah, you should wear gloves. Get everything cleaned up, and I think we're gonna each make our own set of everything, and then see which one of us can actually get some glowing bacteria.
All right, it's on.
So the first step, all we're doing today, this is the first day that we're doing this, and we are just making the plates, like auger plates. But it seems pretty simple. So the first step is to take this LB auger media, and then we're gonna mix it in here with 150 milliliters of water. So we need to get that.
Okay.
Maybe get that big thing that you use for coffee. It feels like very strange to be doing in a living room. Okay, so it says shake vigorously. Do you want me to shake, or do you want to shake?
You shake. Do the honors.
Okay, then we have to put this in the microwave for a few seconds at a time.
To the microwave.
You can see my hand.
Yeah.
I think that's probably good enough.
I'd say so.
And now we're gonna make the plates, and this is where the bacteria are gonna grow. We have to make 2 with this media, and then we're making 5 with another media, but I'm not gonna record all that. Erin and I are each gonna make our own bacteria, so this will be your plate where you grow your bacteria.
Nice.
That's all we have to do at this stage, I guess, is fill these about halfway.
Okay, what's next?
So just put the cap back on, and we let them sit for at least an hour for use. Make it cool them faster by putting them in the fridge. So yeah, I guess we'll just let them sit for about an hour, and then we'll be back. So we waited an hour, and these auger plates are now all set and ready to go. So next we have to make competent bacterial cells for transformation. To take the DH5 alpha centrifuge tube, which we have over here. That's, I guess, just E. coli bacteria, but it's non-pathogenic. So hopefully we don't get E. coli. To prepare the bacteria, add 100 microliters of water from the microcentrifuge tube labeled sterile water to a bacterial tube. Then we shake for 1 minute to ensure the bacteria is dissolved. Pipette all the contents of the tube to the LB auger plate, and then we spread with an inoculation loop, and we let the plate grow overnight at room temperature for 1 or 2 days, or until you see whitish bacteria begin to grow on the plate.
Okay.
Which one do you want?
That one. Don't ask me why.
Okay, I won't. We put 4 drops in here, and then we shake for a minute. Alexa, set an alarm for 1 minute.
I'm not ready. Alexa, stop.
The next step is to pipette all contents of the tube onto an LB auger plate. So that's yours, this one's mine.
And then you just drop it in.
Yeah, just kind of like get it up this. And then here's your inoculation loop.
What is an inoculation loop?
It is used to inoculate the plate. So there's a little...
What does that mean?
It's just to spread it. You have to be light with these because it's kind of like this gel. Just kind of like spread it in this Z-like shape. So then we recap it, and then we just have to leave them somewhere that they can incubate in relative warmth. So we'll just probably leave it over there. And then we'll be ready to do the actual genetic engineering once it grows tomorrow. That'll be fun.
Can't wait.
So this is how the plate looked about 24 hours after we inoculated it. There wasn't any growth yet. I was slightly concerned, but I wasn't gonna let this stop us. So I put it in the bathroom with a space heater overnight to see if that helped at all. Okay, so we got some bacterial growth on our plates after 2 days, and today we're going to do some actual genetic engineering. Today we'll have to just weaken the bacteria's cell walls in a mixture, mix it with some jellyfish DNA plasmid, incubate it in the fridge for 30 minutes, and shock it with warm water for 30 seconds. Then we'll feed the cells with some media and leave them to uptake the DNA for about 2 to 12 hours. Then we pretty much just spread the new bacteria on a new plate, let it grow overnight, and if we did everything right, we should see some glowing bacteria in like a day or two.
If we did it right.
You got way more than me.
Nice.
Using an inoculation loop, gently scrape some bacteria off your fresh plate till the loop is filled and mix it into a tube of 100 microliters of bacterial transformation mix. And just take some of these cells. I'm gonna get some on the corner of the eggs here.
Why?
I don't know. Mix it in here until it's cloudy.
Is that enough?
A little bit more.
Okay. Wait, why are we wearing gloves? Is it to prevent contamination with the bacteria? Or is it to prevent the bacteria from contaminating us?
Yes.
Which one?
Both.
Oh. Is this like dangerous bacteria?
It's E. coli.
So yes.
Well, it's not supposed to be. It says it could be.
Oh. I'm glad this is a widely available product that is sold to consumers.
Okay, then get your tube labeled plasmid.
No, hold on.
Okay, so it says get your tube labeled plasmid, fill it with 50 milliliters of water, which is apparently 2 drops with a pipette.
Oh no, there's a hair on my pipette. Not very sterile.
Just try to get like, oh, it's glowing.
Got a little bioluminescence going on.
It says add all these contents to the competent cell mixture, which is this.
Do you think there's anything in our lease about engineering bacteria on the premises?
There isn't. I've read the lease.
Oh.
Did you spell that?
Oh. Nope, it's good. This is kind of a wild thing to do, just casually on a Tuesday night. We're back.
Okay, so refrigerated these for half an hour, got some hot water, and we're gonna heat shock them. Just took them out a few seconds ago. Do you have your timer ready?
Yep, ready.
3, 2, 1.
Okay.
Okay, that's yours. And then we're just gonna take some of this agar mixture. I guess it's similar to agar. It's bacteria food. We're gonna take this bacteria food and mix it in with our mixture.
Oh, just got it on my glove.
And then it says to flick it.
Okay, wait.
To mix. And then it says the longer that we wait for it to mix, the better it'll work out. Well, it says 12 hours, up to 12 hours. So yeah, we could do it tomorrow morning and hopefully we get some bacteria.
Sounds good.
The next morning, we just quickly inoculated the con agar plates and put them back in the incubation room to hopefully grow some glowing E. coli. We've got all the bacteria here and they've grown overnight. These are the original plates and these are the plates that grew over the last few days and should glow if we did everything right. So we're supposed to take this blue light and shine it on the glowing plate and we should see some green glowing. And we're also supposed to use this UV filter to help see some of the greens. So let's give it a shot.
All right.
This is the original plate. This is blue. And if we put the UV filter over it, it's so hard to tell. The UV filter makes it kind of green. Either way, like regardless, it turns the light kind of green. So I don't know how useful this is or how well we're gonna be able to tell. So this is the plate that was genetically engineered. So we should see more glowing here. It smells bad.
Looks about the same.
Yeah.
Looks blue. Looks green. Okay. Looks blue and green.
Yeah, it might be too bright in here. I brought the plates into a darker room to see if that would maybe make it easier to see some of the glowing. I don't know. I actually think it looks like the engineered plates had a little bit of glowing going on in the dark. Let me know what you think in the comments. I don't know. What's the verdict? Can you genetically engineer stuff at home?
Maybe not.
You probably can, but I don't know if this worked, which it's difficult to do at home. You might not get the results that you want, so.
And you have to house E. coli in your home.
Did you have fun at least?
It was fun. I enjoyed playing scientist for a day.
Do you think you would purchase something more advanced than this to try it out? Would you want to genetically engineer something more difficult?
I'd say no. I don't feel like I'm qualified personally. I also don't feel like I have the right environment to do this, like the right, sterile, controlled environment. We did this on our outdoor patio table in our living room. And we incubated them in a bathroom with a space heater.
So overall, was this at least fun? Yeah, I won't lie, having E. coli bacteria and other scientific materials around where I eat and relax wasn't necessarily my favorite thing. I tried to be as sterile as possible, but it still felt wrong to be performing this kind of experiment in the same space that I live in. I think for those reasons, I kind of hesitate to say whether or not I would really recommend these kits to a lot of people. They were educational and neat, so I think for the purposes of this video, they were worth it for me. But I think having dedicated spaces to perform scientific experimentation is also pretty important. This is the perfect kind of thing to do in a controlled laboratory setting in school or something like that. In fact, I'm pretty sure I did something very similar in my high school and college labs. I think at the very least, this is meant for someone who has a spare microwave and a space that they don't use for food. I do appreciate that Joe Zahner is trying to make genetic engineering more accessible to the general public, and I think they're doing a great job in a lot of respects, and I wish them luck in the future. Obviously, medicines that cost hundreds of thousands of dollars are very inaccessible to many people, but on the other side, it's also unlikely that someone like me is going to be able to genetically engineer medicine in my own home. There may be better ways and other angles to attack this problem from, is all I'm saying. Do I believe that the average person is going to be able to genetically engineer anything meaningful in their homes in the near future? Beyond maybe genetically engineering food at home, I don't really think so, and even that sounds pretty dangerous. I honestly can't even think of many reasons that you would want to genetically engineer something at home. I'm a trained biologist who used to take care of neurons and lung cells for years, and even I ran into problems with this experiment. I'm not even positive that it worked, and I can't say that I felt 100% safe during this experiment either. But I don't know. Maybe I'm biased, maybe I just don't get it and I'm part of the problem. But if this was a kit that was designed to genetically engineer animal or, God forbid, human tissue, and then I made a mistake, then I think the consequences would have been much bigger. The Odin even says science doesn't always work on the first try, right, in their little instruction packet. It's fine when science goes wrong and the only problem is that your E. coli isn't glowing green when you shine a blue light on it. It probably wouldn't be fine if people started performing gene editing at home to try to grow tongues on their hand or something. And people would try that. Luckily, it seems like the Odin is aware of the risks behind what they're doing and will hopefully continue to operate in an ethical way. The risks of genetic engineering are very real and something that we, as a society, are going to have to contend with very soon. People rightfully have concerns about playing God, losing genetic diversity, environmental risks, and uneven social and economic distribution of this technology. Releasing genetically modified organisms into an environment or having designer babies, for example, could have unintended consequences further down the genetic timeline. I wanted to go deeper into the ethics and even talk about some of the cool technologies that are being developed right now under more controlled circumstances. But this video ended up being way too long and all about the kit, so I'm planning on doing a part 2 where I talk more about that stuff in the future, which is good because I did a ton of research for this video that I didn't get to talk about, and I really enjoy talking about this stuff. So if you're interested in seeing that video and hearing more about genetic engineering and other cool biotech topics, please subscribe and comment on this video what you'd like to see me talk about more in part 2. I think to conclude this video, I can at least safely say that we don't have to worry about anybody genetically engineering monsters in their garages anytime soon. Although, to be fair, some might argue that's already been done. I provided links to everything I talked about in the description box below. I hope you enjoyed it, that you learned something, and that it's inspired you to learn more about genetic engineering and other cool science topics. But right now, I think it's time for me to go. Island of Dr. Moreau isn't going to read itself. Bye.